To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter, we discussed about the refraction of light. Now within this chapter, we'll be discussing about several effects created because of the refraction of light. Now first of all, to identify the first and foremost effect of the refraction, you are given with an experiment over here. So within this experiment or else within this activity, we'll be investigating about the apparent elevation of the bottom of a pond or a container of water, the apparent elevation. Now I think you have observed when you are going to take a swim, okay, or else when you are going for a certain area that has a pond or else a water body like a water pool. When you go and check the bottom of the water like this, you may have seen that it is been raised somewhat, right? It is observed as the bottom of the water container or the water pool has been raised somewhat. So this effect is actually happening because of the refraction, right? It is going to happen because of the refraction of light. So we'll be investigating about this refraction, right? And we're going to observe about this apparent depth and the real depth within this activity. So to do this thing, we'll be needing these materials: a beaker, then some water, then a coin, and to mark out the levels, a marker or else a pencil. Right, marker or a pencil. Right, so these are the materials that we need. So in order to mark the apparent level and the real level, we'll be needing a marker or else a pencil, my dear children. Okay, right. So let's head on to see the method then. So the method: put the coin or the nail into the glass tumbler or the beaker, fill it with water. Observe the coin or the nail from the above. Mark the apparent bottom, the coin or the nail, when viewed from the top on the side of the vessel using the pencil. So you have to observe like this. You have to observe and you have to mark the coin or the iron nail, right? Which can be observed when you're observing like this. So you know that the coin or the nail is at the very bottom of the flask. However, you have to observe it like this and you have to mark it. Mark the area, mark the bottom or mark the coin level of the coin, which when you are observing it like this, okay, as per the given figure over here. So now my dear children, what do you have to do? Now measure the real depth and the apparent depth to the bottom of the vessel and note them down. Now what do you have to do? You have to measure the apparent depth and the real depth, the difference between the real depth and the apparent depth. Okay, so this is our activity. Actually, you don't need to measure, right? Measuring is not that much relevant. However, try to identify the two levels, where the real depth and where the apparent depth. Okay, right. So I hope that you got the idea of doing the activity. So now let's head on to the laboratory, right? And we'll continue with the activity given here, and let's identify the apparent depth and the real depth, my dear children. Okay, so let's head on to the laboratory and we'll continue with the experiment then. So my dear children, within this activity, we'll be observing, due to refraction of light, what kind of incidents which we can observe, especially when we are observing certain thing which is located at a bottom of a water container. Okay, so in order to observe that, I have a glass with me. So what I'm going to do is I'm going to pour some water. So it is a glass container now that has water. So now I have a coin So let's insert the coin like this. And when we are observing from the top, we can see the bottom very carefully without any trouble. However, when you are observing it from an angle like this, you can observe that the coin has raised somewhat, not at the original position. Right, my dear children? Now, when I'm looking like this, when I'm looking like somewhat, like we can't directly see it like this, you go somewhat back and observe the container. So when observing the container like somewhat backward, you can observe there are two different depths. Actually, I can see here very clearly, even for you guys now, even for you guys also, you can see it very clearly from the video. See, there are two different depths. This is the original depth. This depth, which is over here, is the apparent depth. So as you can see here, my dear children, this is the actual coin, and there is another coin like over here, right? Like in this area, we can observe another coin. So that's the apparent depth of the apparent depth means, my dear children, here that's the one which we can observe. However, the real depth is somewhat way more greater than that. So we'll mark that apparent depth and we'll observe how much height between the real and the apparent depth. Okay. So, right. So this is the point, my dear children. I have marked the point. Right. Now, as you can see here, this is the depth of the coin which I have marked. But however, that depth is not the real depth, my dear children. The real depth is like over here. So this is the real depth of the coin, my dear children, like in this kind of a area. However, this is the apparent depth which I have marked according to my vision. So this change of depth is created because of the refraction of light rays, right? So this level which I have marked over here is referred as the apparent depth of the coin. And over here you can observe the real depth. So there is a clear difference between the apparent depth and the real depth, my dear children, when you are observing a certain thing, right? Actually here, a water container or else a liquid container. In here we used water. So when you are observing a water container, there are two different levels as the apparent depth and the real depth. Why do we need this thing to identify? It's mainly because sometimes when you go in for a swimming in a like in a watery area, you might feel that now this area is not that much deep. But however, the actual depth can be observed when you come and when you go into that particular water, when you go into that particular watery area. So the real depth is way more, as you can see here within this container also, there is a huge difference between the real and the apparent depth. So the real depth is way more greater than the apparent depth, my dear children. So it's when you guys are going to a watery location, like a lake or else a tank or something like that, or else it can be a pool. So when you are going to a place like that, first of all, make sure that it's not that much deep, right? So don't go ahead and jump into those kind of things, those kind of areas, because it will be harmful for you guys, because actually the depth which we can observe is not the real one, that's the apparent depth. Okay, so this phenomena is occurring because of the refraction of light rays, my dear children. Right, now let's head on to the classroom once again and we'll observe what are the other effects of refraction. Right, my dear children, so we did the activity and you can clearly observe the difference between the two levels, right? So there is a clear difference between the two levels of the real depth and the apparent depth. So we can appear, or the real depth is going to appear for us somewhat has been somewhat raised. It's because of the refraction of the light. Okay, so the real depth is going to raise somewhat and that raised level is the one which is being appeared over here. That's the one we are being observed, and we even mark the level on that beaker. So my dear children, right, here we can write down the observation. It's very simple. There is a clear distance between right. So this is the observation. There is a clear distance between apparent depth and real depth of the water level. So there is a very clear difference between the apparent depth and the real depth of the water level. Right. So my dear children, as per to the observation, you can see that. So there is a clear distance. There is a clear distance. Distance means there is a clear gap. I'll mention as gap instead of distance. I'll mention as gap. Okay. So there is a clear gap between apparent, right, apparent depth and real depth of the water level, right? So there is a clear gap between the apparent depth and the real depth of the water level, right? So there is a clear gap between the apparent depth and the real depth of the water level. Why? Because my dear children, here the bottom seems to us as somewhat raised, mainly because of the refraction of light. So refraction of light rays cause the difference between, or the gap between, the real depth and the apparent depth. So we can write our conclusion. Refraction of light cause the gap between apparent depth and real depth. So refraction of light causes the gap between apparent depth and real depth. This is the reason, or this is the conclusion for that observation over there, right? So my dear children, these are our observations and our conclusions. Once more, let's see. So there was a clear gap between apparent depth and the real depth of the water level. Then my dear children, refraction of light caused the gap between apparent depth and real depth, right? So these are our conclusions and the observations from the activity, right? Then, so it is clear that the observable depth, or the apparent depth when viewed from top, is always less than the real depth from the water surface to the bottom. So my dear children, when we are observing from the top a water container, water pool, we can see that the actual depth, right, we can see not the actual depth but the apparent depth. Always the actual depth is way more deeper than the apparent depth, in any kind of a water pool when you're observing from the top. So this incident or this phenomena is going to occur mainly because of the refraction of light. So here it is given. It is important to think carefully before step down into a well or a reservoir, because the real depth of it is more than the apparent depth. So my dear children, the other thing is that if the pool is somewhat deeper, then higher the deeper or higher the deep, right, or higher the depth, what will happen? The apparent depth, the distance between or the gap between the apparent depth and the real depth is also going to increase, right? So higher the depth, higher this gap. So that means, my dear children, right, we should have to be very careful when you are setting foot on a certain reservoir, or when you are going to go to a certain reservoir or else a water pool. It's because that the real depth of these things could be even more, right? So you might drown if you think, now by just looking at it, you might think that now this is not that much deep, and you will jump into the reservoir. Then, however, after getting into the reservoir, you will get to know that it's somewhat deeper. It's because of that difference between the two depths. The one that you see is not the real one. It is happening because of the refraction of light. Okay, right then. So for extra knowledge, it is given here. Birds like kingfisher observe fish in water a little above than where they actually are. But those birds have an idea of the real depth to the fish. So a kingfisher, you know, like kingfisher are going to catch fish, right? So when a kingfisher is observing a fish which is placed at the bottom, right, the kingfisher is observing this fish, right, not at this level but somewhat above it. But however, the kingfisher has the idea of the location of the fish. Okay, so that idea is going to help for the kingfisher to catch that particular fish. Okay, right, my dear children. So this is the first and foremost effect of refraction, which is the apparent depth and the real depth. Okay, right then. Now let's head on to see the next one. So pencil dip partially in water seems to be broken at the water surface. So when you insert a pencil like this, my dear children, we can clearly observe that the pencil has got separated into two lines like this. One half is over there and the other half is over here. Like that way we can observe it. With if you insert a pencil into a water container, a glass of water like this. So here, a pencil which is partially dipped in water seems to be broken at the liquid surface when viewed from a side. The reason for this is the refraction of light when it comes from the water to air. So when light rays are coming from water to air, what will happen? The light rays are getting refracted. So because of the refraction, we can observe there is a clear separation, or there is a clear separation between the two lines of the pencils over here, right? So for us, it is observed that the pencil has got separated into two lines. But however, it's not been separated. The same pencil is there. This phenomena is happening mainly because of the refraction of light, my dear children. So when you insert a certain thing to a glass of water like this, then we can observe as two different parts because of the refraction, right? This is happening because of the refraction, my dear children. Right. So this is the second effect that is going to happen because of the refraction. Okay, right, my dear children. Now let's head on to the laboratory and we'll get this pencil and we'll dip it in a container of water, and let's see whether we can get the same observation or not. Okay, so let's head on to the laboratory, my dear children, and we'll continue with this activity, and let's find out whether we can identify these two parts within the pencil or not. Okay. So my dear children, within this activity I have a pencil with me. This is the water container. What I'm going to do here is I'm going to insert the pencil into this water container, and we are going to observe whether there is any deviation between the lines of the pencil and the pencil which has been inserted, part of the pencil which has been inserted to the water. Okay, right. So when you insert it like this, my dear children, and when you go and observe it like this, there is a clear deviation with the path, right? Actually, it's been bent right now like this. There's a clear bend. There's a clear bend like this. We can clearly observe that bend. And even you can observe that the pencil has somewhat, like zoomed in because of the refraction of light through the water. So this effect of bending is occurred. Now you can see that the pencil has bent. So this effect of bending is occurring mainly because of the refraction of light rays, which is coming from the pencil, which is at the container, water container. Okay, so when the light rays are coming towards you guys through the container, right, it is getting refracted, so that the refraction is observed as the bending, right? So this is the next step or the next phenomena related to the refraction of light rays, my dear children, right? So let's head on to the classroom once again, and we'll observe the other contents in the lesson day. So my dear children, like in the figure, in the same way, we could observe the two different parts of the pencil because of the refraction of light. So this is the second effect, my dear children. What is that? The pencil which is partially can be observed as two different parts which is broken like this because of the refraction of light rays. Okay, now let's head on to see the next activity or the next effect. Actually here an activity is given. Now within this activity, my dear children, we are going to find out, right? We're going to find out how the refraction of white light is going to happen through a prism. Alright? Refraction of light which is going to occur through a prism. So this is a prism. So this prism is made with glass. You know what do you mean by a prism, right? Like in the kaleidoscope, right? Here the entire surface is made to that kaleidoscope shape or the prismatic shape, right? And it is made up with transparent glass, right? Made up with the transparent glass. So here we are going to direct a beam of white light. White light means sunlight. We are going to direct sunlight towards the prism, and we are going to observe what is going to happen with that light. Okay, right. So let's see how to do this activity, but before that we have to get the materials that we need. So here first of all we'll be needing a prism. Then my dear children, we'll be needing a white screen. Then a cardboard. Then a mirror. Right? Then we'll be needing a mirror. So we'll be needing this mirror, my dear children, in order to reflect a good beam of light towards the prism. Now we have to place the mirror outside, or else if you have the prism with you guys, you can just go for the outside and you can do the activity. But here what I'm going to do is I'm going to place a mirror outside the laboratory, and I'm going to take a beam of light towards the prism through the reflection, right? Then I'm going to direct that beam of light through the prism. Then going to observe what is going to happen over there. right? So I'm using this prism as the reflective media, right? So these are the materials that we need, my dear children. So we'll be needing a prism, a white screen, a cardboard, and a mirror, right? Right. Then let's head on to see the method of the activity. Right then. So here it is given method. Keep the glass prism on the table. Direct a narrow beam of light on the prism using the plane mirror and the piece of cardboard. So using the piece of cardboard and the plane mirror, you have to direct a beam of light towards the prism as per to the figure given here. See? So this is the white light ray which is coming towards the prism and it is getting refracted, and you can clearly observe that it is going to fall onto that white screen over there, right? Then my dear children, let the light that passed through the prism fall on the screen. Now what you have to do? You have to allow this light ray to fall on the white screen, right? Discuss the reason for your observations in the classroom. Now, in the classroom, after that, we are going to discuss what is the reason for that particular observation. Okay. Actually, what is going to happen here is the white light is getting separated into 7 colors, which are the colors of the rainbow. Okay. The rainbow, it is getting separated into rainbow colors. Right. So my dear children, let's head on to the laboratory now. Actually, we are not going to go to the laboratory right now. We're going to go outside and we're going to do this experiment by using the prism. And my dear children, let's see whether we can get this observation or not. Okay, so let's go to the outside and we'll continue with the activity. So my dear children, within this activity, we'll be investigating about the refraction process. The process of refraction that is going to occur especially through this object. This particular object is referred as the prism, a triangular prism. So this triangular prism has 2 triangular surfaces at the either sides, and on the 3 other sides, like these 2 sides and the below, there are 3 rectangular surfaces. There are 3 rectangular surfaces like this, 1, 2 and 3. And at the either sides, there are 2 triangular surfaces. So this is the one which is referred as the prism. So when you take a prism, my dear children, prism has the ability to refract light rays, right? So as it is made up with glass, when a certain light ray is coming through the prism, it's getting refracted. A special thing here is that when the white sunlight is getting refracted by the prism, it's getting divided into 7 light rays. So it's getting refracted into 7 light rays. Our white light, my dear children, the white light contained within the sunlight is getting created, it's been created with 7 different colors. These are the colors that we refer as the rainbow colors, right? These are the colors that we refer as the rainbow colors. So this white light is getting separated into those 7 different colors when this white light is passing through a prism. So to direct a beam of light towards a prism, we can use this mirror. You know that when I direct this thing to you guys, you can see that it's getting like reflected, right? So this reflected surface can be used to get a bright beam of light towards the prism. So by that way, like this, you can direct this thing towards the prism and you can get a bright beam towards the prism so that it would refract and create those 7 colors. So by using the prism, we can get the 7 colors, my dear children, right? Now let's observe how to get these 7 colors. Right, my dear children, now in here, as you can see, now I have came to the outside because we have to get some bright white light rays or sun rays. So here now I'm using that reflector, which is the plane mirror, right, to get a direct light beam. So as you can see here, now it's somewhat blurred, but I'll try to make it to a right. Now as you can see here, somewhat blurred, but I'll try to make it to a color that we can see, the 7 colors. Right, now as you can see here, starting from red, right, yellow, then green we can observe, then blue, like that there are 7 different colors, right? So this white light is coming directly from the sun. So as you can see here, it's very obvious to us that, right, the color is getting divided into 7 different colors. So this is the mirror which I have planted over the near to my prism, my dear children. So it is getting reflected, see. So as you can see here, so this mirror can be used to reflect the light rays towards the prism. Right, my dear children, I think you have observed what has happened over there. So we have used this prism in order to refract the white light, and we divided that white light by using the prism into 7 different colors. So these are the colors that were named as the rainbow colors. Right, my dear children. So once again, we'll head on to the classroom and we'll conduct the other lesson parts related to the refraction lesson. Right, my dear children. So it is quite obvious to us. I think you could clearly observe the 7 different colors. Okay. So the white light or the sunlight is going to separate into 7 different colors when passing through a prism. Right. So by that way, we can come into a conclusion that white sunlight contains 7 different colors. Okay, 7 different colors. Right then, so we'll write down our observation. 7 different colors right, 7 different colors. That means colors of the rainbow. Is observed. Right. So 7 different colors of the rainbow is observed. Then conclusion. Conclusion is very simple, my dear children. White sunlight contains white sunlight contains 7 different colors. So white sunlight contains 7 different colors. This is our observation then. Okay, right? And from that observation, the conclusion. You know that 7 different colors or the colors of the rainbow is observed over here, right? Colors of the rainbow is observed here. I'll mention as colors of the rainbow. That would be more convenient, no? Because actually we won't be able to observe, right? We won't be able to observe the 7 different colors in detail over here. However, we can observe the colors of the rainbow, right? Rainbow colors can be observed for sure. So here we can write down as like this: rainbow colors. Are observed. Okay, rainbow colors are observed. Right, so this is within brackets I'll mention as 7 colors. So you know that the rainbow contains 7 colors. So within brackets I'll mention the 7 colors. So rainbow colors are observed. This is our observation. Then, my dear children, from that observation, we can come into a final conclusion that white sunlight contains 7 different colors. Okay, white sunlight contains 7 different colors. Those are the colors that are identified within the rainbow then. Right, my dear children? So this is our activity then. Right? From the activity, these are the observations and the conclusions that we took. Right? Then let's head on to see the other contents. So here it is given a spectrum of 7 colors can be seen on the screen during the activity. Yes, a color spectrum could be observed, right? So when we are doing the activity, we could observe the spectrum of colors, 7 different colors. Then here it is given once more. Separation of white light into 7 colors when passing through a prism due to refraction is the reason for this. Now over here, my dear children, what is going to happen is, here the separation of white light into 7 colors when passing through a prism is the reason, right, is the reason for having these 7 colors. Actually, the white light is the one which is getting separated into these 7 different colors. Okay. The colors of the spectrum are, the colors of the spectrum are given according to the order with the respected color within here. So red, orange, yellow, green, blue, indigo and violet. Right. So like this, the white light is getting separated into 7 different colors when it is passing through a glass prism. Then the important fact. Separation of white light when passing through a prism is known as dispersion. Dispersion. So dispersion of light rays has happened over here. That is why, my dear children, the light rays are going to separate into 7 different colors. Okay. So white light is getting separated into 7 different colors because of the dispersion, right? Because of the dispersion. Right then. So for extra knowledge, a certain thing is given here. Let's see what is that. Scientist Sir Isaac Newton showed that the white light is composed of 7 colors. The equipment he used for this is known as the Newton's disc. Newton's disc is made by painting the segments equally divided through the center of the circle with the 7 colors. When this painted circle is rotated, the 7 colors mix to give the white color. You also can make a Newton's disc if you are of your own. Right. Now this instrument is referred as the Newton's disc. This Newton's disc, prepared by Sir Isaac Newton, a great scientist, in order to prove that the white sunlight contains 7 different colors, the colors of the rainbow. So he used this equipment, he rotated it quite fast. Then he showed that upon the rotation, the structure or the disc is going to show a white nature, a white color. Okay. So my dear children, by that way he proved that the white light is also composed of 7 different colors. Here the disc is made by separating into 7 segments. Okay. Within these 7 segments, the rainbow colors or the colors of the spectrum could be observed. So what Newton did is, he's going to rotated the wheel quite fast and observed what's going to happen. Then by that way, he clearly showed that when rotating this thing quite fast, we could observe the white color. This white color is actually observed as a as a hallucination, and actually it is composed of 7 different colors. That's the correct idea, right? So my dear children, I hope that you got the idea of the dispersion. Okay, so this dispersion is the process of dividing white light into 7 different colors, which is the color of the spectrum. So my dear children, I have prepared a certain Newton discs. Okay, so let's go to the laboratory and we'll identify whether we can get this observation or not. Okay, so I'm going to rotate my Newton disc at a certain speed and observe whether you guys can get the white color nature or not. Actually, we won't be able to observe 100% in white color, but however, when I'm going to rotate this thing up to a certain level, a white nature, a white surface could be seen very clearly. So let's head on to the laboratory, and my dear children, we'll rotate this Newton disc and let's observe whether we can get the same observation as the Newton. Okay, so let's head on to the laboratory and we'll rotate this thing and we'll see whether we can get the same observation or not. So my dear children, this is the instrument which is called as the Newton disc. So this Newton disc is consisting several colored portions of a circle, as you can see here. It is this kind of a thing, right? So Sir Isaac Newton was the first founder of this thing. He was a great scientist, you know that, right? So he was the first person to introduce that the white light is composed of 7 different colors like this. So these are the colors actually we identify in the rainbow. So now when I'm going to rotate the wheel of the Newton disc, you can observe actually the white color instead of these 7 colors. Now you can clearly observe there are several colors in the disc. Actually, there are 7 colors. So, however, even though it is showing 7 different colors in the still position, and I'm going to rotate it very fast, it will definitely turn into white color. So that's how the normal light rays are getting created. Normal light rays means including the sun. Light received by the sun. So the sunlight is also composed of these 7 different colors. I think you could remember that we studied those things under the refraction of white light through a prism. Okay, right, now let's rotate this thing and we'll observe whether we can obtain the white color or not. So you have to rotate very fast, my dear children, like this. So now you can see when rotating very fast, right? When rotating very fast, we can observe the white color, my dear children. Observe the white color. Right. I think you can observe the white color very well. When I'm slowing it down, once again you can observe the same disc which is composed of the colors. Now when I'm rotating it once more, right, you can clearly get the white color. See, right then. So my dear children, this is the instrument called as the Newton discs. So let's head on to the classroom once more and we'll observe the other contents in the lesson. So my dear children, as you can see, it's very clear to us that, right? I hope that you got the idea. You have seen the rotation very well, and with the rotation, I think you could clearly observe it is going to show a white nature when I'm rotating it very fast. Okay, so this was first conducted by the great scientist Sir Isaac Newton. That is why the above disc was called as the Newton's disc. Right then, so let's head on to see the next content. So the next main effect of refraction of light is given the occurrence of rainbow. So you are given with a point. Rainbow is another elegant phenomenon that occurs due to refraction of light. So rainbow is a wonderful phenomena that happens in our environment because of the refraction of light. because of the refraction of light, this phenomena, which is referred as the occurrence of rainbow, is going to happen. So rainbow is going to happen it's mainly related with the rain. Okay, so my dear children, like I said, the rainbow is somewhat related to the rain. So when a heavy rain or else when a drizzle is going to come down, and when the sunlight is passing through these water droplets, the same process which has happened over there within the prism can be observed over here. So upon passing through the water droplets, light rays are separated into 7 different colors. That's why we can observe the rainbow. Okay, the same dispersion process can be observed, right, within the rainbow as well. The same dispersion process can be observed within the rainbow as well. So the dispersion is the process of dividing white light into 7 different colors. Within the prism also same thing happened. So when light rays are going to pass through a drizzle, I mean like through water droplets, this rainbow can be observed very clearly. Even, my dear children, you can observe rainbow kind of spectrum near a waterfall. It's mainly because now when water is coming down at a higher speed, droplets are going to move here and there. I mean like droplets are going to spread here and there. So upon passing that white light through those water droplets, we can observe a rainbow. That's why even near a waterfall, we can observe this rainbow or the spectrum of 7 colors. Right? Now let's head on to see the content then. So there are various folk tales among people that connection with the rainbow. When there is bright sunlight with mist or drizzle, a rainbow can be frequently observed. So even though there are several folk tales, my dear children, the true scientific idea is the dispersion. Dispersion of white light when passing through water droplets. That's the main reason for the occurrence of a rainbow, right? Rainbow occurs because of the refraction and internal refraction of sunlight by water droplets in the sky. Here, white sunlight is dissociated into colors by water droplets. So, here, my dear children, what will happen? The white light is getting dissociated, or else it is getting dispersed into 7 different colors by the water droplets. The same procedure, same as the prism, right, is going to happen over there also. A large number of water droplets in the sky contribute to form a rainbow. So, large number of water droplets in the sky is going to contribute to form a rainbow. So, this is how the rainbow is going to occur. So, these are the effects of refraction, my dear children. Other than that, the occurrence of mirage is also going to happen because of the refraction of light. Okay. Over there, right now, when a certain person is traveling on a hot environment, that particular person can observe near to the horizon like watery nature. So that nature is mainly appearing because of the refraction of light. Okay, right. So my dear children, this is the occurrence of rainbow. So as you can see, how within the first figure, you can observe how the rainbow is observed, right? It is like, you know, like it is like a curve like thing. See, a curve like thing, an arc like thing can be observed right over here. So this is the rainbow, my dear children, and the rainbow is going to happen, or it is going to occur mainly because of passing white color sunlight through water droplets like this, and upon passing through it, it's getting separated into 7 different colors because of the refraction. So dispersion of light through a single water droplet is given within that figure. So when thousands of water droplets are going to combine together, a rainbow can be observed. So this is the occurrence of a rainbow. Right then. So my dear children, we have discussed every theoretical part related to the lesson. Now it's time to discuss the summary of our lesson. Okay, so first of all, my dear children, we discussed about the bouncing back of light rays to the same medium after striking on a shiny surface. So this incident was referred as the reflection, right? This is referred as the reflection. Light reflect according to the laws of reflection. So there were two laws, my dear children. Number one, the incident ray, normal, and the reflected ray lie on the same plane. Number two, always the reflected angle is equal to the incident angle. So those two were the laws of reflection. Next one, regular reflection and diffuse reflection are the two ways of reflection of parallel light. So parallel light can be scattered here and there, or parallel light can be transmitted or can be reflected parallel to each other as well. So according to that, there can be diffuse reflection and regular reflection. Diffuse reflection is the scattering process. Regular reflection is the process which the reflected light rays are going to travel parallel to each other. Okay. Then the third one, images are formed by reflection of light by mirrors. So we discussed that the plane mirrors are going to create several images because of the reflection process. Images formed by plane mirrors are always upright, virtual, and are subjected to lateral inversion. Upright means same as the object, same direction as the object. It's not getting upside down. Same as the object, it is upright, or else it is also called as erect object. Next one, virtual. Virtual means, my dear children, those things cannot be, or those images cannot be projected into a different screen. The image is created within the mirror itself. That's it. Then, my dear children, lateral inversion. So lateral inversion is the process, okay, where the left and right sides are going to switch. So left and right sides are going to switch in lateral inversion, the lateral inversion. Then when images are formed by objects in front of plane mirrors, the size of the object is equal to the size of the image. Distance to the object is equal to the distance of the image. The other thing, always the size of the object is same as the size of the image. And the other thing is that when you measure the length between image to the mirror, it is getting equal to the distance between mirror and the object. Okay, that means object distance is equal to image distance. Distance between image and the mirror is the image distance. Distance between mirror and the object is the object distance. Okay, distance between mirror and the image distance, that distance is equal to distance between mirror and the object, which is the object distance. Then instances of reflecting light by plane mirrors are used in day-to-day life. So there are different instances where we use the reflection of light rays. Mainly we use these reflections in order to look ourselves as our looking glasses. Okay. Other than that, my dear children, in microscopes, in telescopes, we use these light rays we use this reflection in order to get a good beam of light rays. Then, my dear children, bouncing back of sound by an obstacle is called the reflection of sound. Then we studied about the sound. So bouncing back of sound waves, same as the light, when struck on a certain object or else an obstacle, is called as the reflection of sound. Okay. Then echo and reverberation can be mentioned as two phenomena occurred by the reflection of sound. So because of the reflection of sound, echo and also the reverberation processes going to happen, right? Reverberation is a troublesome stage of echo. Now reverberation is a troublesome one. I mean, it's not a good effect, right? It's a bad effect for us. It's mainly because before the losing of sensation of a certain sound from our brain, the reflections of that particular sound is going to come towards us. So in that case, we won't be able to clearly identify the information contained within the sound. Okay, and we can't distinguishly identify the two different sounds. Okay, so the sound will get jumbled within our brain. Okay, so my dear children, this reverberation is a bad effect given out by the reflection of sound. So therefore, in order to minimize the reverberation which is going to happen in places like auditorium and cinema halls, there are certain different kinds of remedies which are being added, like making the surfaces porous and rough. Okay, so here various methods are used in auditoria, cinema halls and lecture halls to prevent reverberation. Okay, so like making the surfaces rough and, my dear children, having porous ceilings. Next one, ultrasound scanning and finding depth of ocean bed are some instances where reflection of sound is put into use. So the reflection of sound is also used in ultrasound scanning. So ultrasound is a sound wave which is generated by a machine that has a frequency more than 20,000 Hertz, which is the maximum hearing limit of the human ear. Okay, so ultrasound waves have even more higher frequency than that, right? So my dear children, in ultrasound scanning, we use these ultrasound waves in order to get a certain scan of an organ or else to check the condition of a womb and the fetus, because the ultrasound waves are less harmful than X-rays. Then, my dear children, the change of direction of light when traveling from one transparent medium to another transparent medium is known as the refraction of light. So, the bending of light rays or else the change of direction of light rays when passing from one transparent medium to another transparent medium is known as the refraction of light. Actually, we discussed that the refraction is like a hallucination. This change of direction is like an hallucination. That's how we observe these things. That's how we capture the sense. However, within there, what is going to happen is the speed of the light is getting changed, and that speed change is observed as bending for us. Okay, so normally we can mention it as the bending of light rays or else changing the direction of light rays when passing from one transparent medium to another. So this is the one which is referred as the refraction of light. Then, my dear children, finally we studied about the apparent elevation of a bottom of a pond, the dispersion of white light into 7 different colors through prisms forming rainbow are some instances where the refraction of light occurs. And not even that, but also the occurrence of mirage is also a reason of refraction of light. Okay, so these are the things that we have learned within this chapter, my dear children. Okay, right, my dear children. So I hope that you got a good idea about the lesson refraction and reflection of light and sound waves. Now it's time to do our questions related to the textbook. Okay, let's head on to see the questions then. So first question given, select the correct or most suitable answer. So in here you have to select the correct one or the most suitable answer. Select the correct sentence out of the following. So you have to select the correct one. Okay. Regular reflection occurs well from rough surfaces. Incorrect, right? Yes, it's incorrect. Because if the surface is rough, my dear children, if the surface is rough surfaces are going to scatter light rays. So therefore, scattering means not the regular reflection, it's the diffuse reflection. So regular reflection cannot be observed from rough surfaces. So this is incorrect. Next one, angle of incidence is not always equal to the angle of reflection. Once again incorrect, my dear children. because always the angle of incidence is equal to the angle of reflection. Here it is given specifically as the reflection. If it is refraction, then it is okay. The angles are getting changed for sure. But however, within each and every reflection, the angle of incidence is getting equal to the angle of reflection. Okay? That is why it is referred as a law. We can't change it. Next one. Light rays that are falling perpendicular to a plane mirror do not get reflected. We'll keep that thing. Light rays that are falling perpendicular to a plane mirror do not get reflected. We haven't studied about that thing within the lesson part, my dear children. Okay, actually we have studied, but I think you don't get that idea, you don't get the sentence given out, sentence that much clearly. Okay, but however, we'll go for the next one, final one then. Angle of incidence is always equal to the angle of reflection. Angle of incidence is always equal to the angle of reflection. Right. So, angle of incidence is always equal to the angle of reflection. The opposite of the second sentence means definitely this one should be our answer. This is the correct answer. Now I'm going to go ahead and check the third one. See, light rays that are falling perpendicular to a plane mirror do not get reflected. Who says that? It's totally incorrect, no. Each and every light ray which is going to fall onto a surface, I told you that some amount is getting absorbed and the other is getting reflected. No matter the angle which the light rays are going to fall, all of the light rays are getting reflected if they are going to fall onto a shiny surface. Not only to a shiny surface, but onto any kind of a surface. So, my dear children, this statement is also incorrect. Okay, this is also incorrect. I kept that thing in order to show that to find a certain answer, you don't need to check always each and every sentence. Sometimes you can skip sentences. Okay, right then. The second question. Underline the correct ray diagram which shows the reflection from a plane mirror. Reflection from a plane mirror. Quite obvious, my dear children, reflection from a plane mirror can be taken as like this. Why? You know that for sure this is incorrect. This is not reflection. Here the light ray is going to come and travel through like this. So if the light rays are traveling through the medium, then it is not a reflection, it's a refraction. This is totally incorrect then. This is our answer. Let's see the next one. Here you can see that light rays are falling perpendicular to the, right, light rays are falling perpendicular to the mirror surface. Like perpendicular, no? In that case, you know that there is a rule, incident angle should be equal to the angle of reflection. So in that case, the ones who are coming perpendicular to the mirror surface should also reflect and travel perpendicular to the mirror surface like this. Perpendicular lines are traveling in the perpendicular way after the reflection. So this is also incorrect. Next one over there. This is also incorrect. See, falling nearly to an 90-degree angle, then going like this. Falling at an angle like this, then going at an angle like this. As you can see, these two lines are somewhat parallel to each other. So, my dear children, this is also not acceptable. The reason is this. This particular line should not come like this. It should go like this. This one and this one is the correct way. Always remember the incident angle should be equal to the angle of reflection. So, if a certain light ray is coming at 90-degree angle, then always it should travel along the same path after the reflection. That means maintaining the same 90-degree angle. Okay. So the second one would be our answer. Question number 3. Image formed by objects kept in front of plane mirrors are always, images are upright and virtual, subjected to lateral inversion, distance to object is equal to the distance to the image. Of the above sentences, which is are true? Images are upright and virtual, absolutely correct. Cannot be taken into a screen, and these things are upright as well. Subjected to lateral inversion, correct. Left and right sides are getting switched within the plane mirror images. Next one, distance to the object is equal to the distance to the image. Once again correct, object distance is equal to the image distance. So my dear children, the true ones or the correct ones are all. All of these things are correct. Next one, select the correct statement about echo. You have to select the correct statement about the echo. It can occur at any distance between observer and the obstacle. Incorrect. Because we discussed that there should be a minimum distance like 16.5 meters in order to experience echo. Next one, echo can be heard always when sound is reflected. We'll give that thing. Cause for reverberation is not the echo. Incorrect. Cause for reverberation is the echo. Occurrence of echo at the same time interval, I mean like in different time intervals, but before the losing of first sensation in the in the sound. Okay, before losing the first sensation in our brain of this first initial sound, the reverberation is going to happen, or else echoing is going to happen, right? So echo is a main reason for the occurrence of reverberation. That is correct. Next one, reverberation can be eliminated by preventing the reflection of sound. Correct. That's why we are making the surfaces rough. That's why we are making the surfaces porous. So my dear children, our answer should be the second one. It's quite obvious, no? The echoing can always be heard when there is a reflection of sound. In order to reflect this, in order to hear the echo, the sound should reflect and come to us. If there is no reflection of sound, then we won't be able to hear the echo. So it is correct. So the correct statement would be, echo can be heard always when sound is reflected. This is the true statement or the correct statement. White light can be separated into 7 colors by a prism. Conclusion that can be made according to this phenomenon is, light can be refracted by prisms. White light is harmful to the body. White light is composed of 7 colors. Yes, this is the conclusion. Even we did this activity at outside or within our laboratory. Outside the laboratory, we did this activity, and you could clearly observe that the white light is getting separated into 7 different colors by the prism. By that way, we came into a conclusion that white light is composed of 7 different colors. Next one. Select the instances out of those given below which are associated with only the refraction of light. Only the refraction of light, okay? First one. Looking at the face using a plane mirror. So you have to select only the refraction of light. So this is incorrect. This is regarding a mirror. So within a mirror, we won't be able to observe refraction. Here we are observing the reflection. So it is incorrect. Benching of light when passing through a block of glass. That's correct. No problem. It is correct. Seeing a pencil broken at the surface when it is put into a container of water. Of course, it is correct. That's an effect given out by the refraction of light. Next one. Occurrence of multi-images in a kaleidoscope. Once again incorrect. In the kaleidoscope, we can observe multi-images because of the plane mirrors. So plane mirrors are creating reflections, not the refractions, right? So You have to select the ones which are associated only with the refraction. So B and C should be our answer. Yes. Over here there is B and C. Then the question number. Right. Now here you have to write down the correct answers. Let's see. Explain briefly the following terms which are associated with the reflection of light. Incident ray. Reflection of light. Very simple, my dear children. Incident ray is the light ray which is coming towards the mirror surface. Okay. So light ray which is transmitted towards the mirror surface. So light ray which is transmitted towards the mirror surface is the incident ray. Then the reflecting ray. Light ray which is getting bounced back after struck or after the reflection. Then you can write light ray which is reflected back after being struck on a reflective surface. So light ray which is reflected back after being struck on a reflective surface is the reflecting ray. Okay. The light ray which is reflected back after being struck on a reflective surface. Then my dear children, number 3, normal line. This is the perpendicular drawn to the surface of the mirror, or else perpendicular drawn to the reflective surface through the point of incidence. So perpendicular drawn through point of incidence perpendicular drawn through point of incidence to the reflective surface. Right. So perpendicular drawn through point of incidence to the reflective surface is called the normal line. This is the one which is called as the normal line. Next one, angle of incidence. Very simple, my dear children. This is the angle between normal and the incident ray. So angle between normal and the incident ray. So angle between normal and the incident ray is the angle of incidence. This is the angle of incidence. So normal line is the perpendicular drawn through the point of incidence to the reflective surface. Angle of incidence, it is the angle between normal and the incident ray. Then the angle of reflection. So angle of reflection, very simple once more, it is the angle between reflected ray, angle between reflected ray and angle between reflected ray and the normal. Angle between reflected ray and the normal. This is the angle of reflection. Okay, let's see the next one. In a school where multi-storied halls are situated close to each other, the noise of students in classes at upper stairs are heard closely by the students in downstairs. What is the reason for this? Now, in a school where multi-storied halls are situated close to each other, the noise of the students in classes at the upper stairs are heard closely by the students in downstairs. What is the reason for this? As there are multi-halls with multi-buildings, the students who are going to emit the sound at the top, okay, is going to emit sound waves, and these sound waves are reflected back several times with the help of those buildings. And my dear children, these reflected sound waves going to travel towards the students who are at the lower level. So my dear children, it can be clearly heard by the lower level students, right? Like that these students who are shouting at the upper level are somewhat closer to those guys. So this is happening mainly because of the reflection of sound when they are going to struck on buildings. Okay, so we can write the answer. First of all, we can say that due to reflection of sound waves, due to reflection of sound waves by buildings, right? Due to reflection of sound waves by buildings, because here they are saying that multi-storied halls are situated close to each other. So due to reflection of sound waves by buildings, the students who are at the the noise of the students in the classes at the upper stairs are heard closely by the students in downstairs. So students who are at the downstairs so due to reflection of sound waves by buildings, the students who are at the downstairs can hear the sound well, right? Can hear the sound well. So here I'll mention as students who are at the downstairs can hear the noise of the students. Can hear the noise of the students. Right. So the question once more. In a school where multi-storied halls are situated close to each other, the noise of students in the classes at upper stairs, noise of the students who are at the upper classes, are heard closely by the students in downstairs. So due to reflection of sound waves by buildings, the students who are at the downstairs can hear the noise of the students at upper stairs well, right? So because of the reflection of sound, the students who are at the downstairs, they can hear the sound or the noise of the students who are at the upper stairs. Okay, so this is our reasons for that question, my dear children. Right, then the next one. A student aimed a lighted electrical torch with an inclination from the top of the fish tank to observe its bottom. But unexpectedly, the beam of light bent at the water surface. Explain this phenomenon scientifically. So, this bending is going to happen because of transmitting light from one transparent medium to another. This is also referred as the refraction. Okay, so we can write the answer. When light is passing from one transparent medium to another, so when light is passing from one transparent medium to another, light rays are refracted. Therefore, the beam of light will bend. So my dear children, you know that when light is passing from one transparent medium to another, right? See, here we can put a comma. So when light is passing from one transparent medium to another, light rays are refracted. Therefore, the beam of light will bend. So this is our answer for the question. So my dear children, we have answered for each and every question given in your textbook. Okay, so now it's time to do several extra questions related to the lesson part. However, we'll be discussing these extra questions in our next chapter. So I'll be hoping to meet you guys with our next chapter, with our final chapter, to discuss the extra questions related to the lesson.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.